Hey guys, what's up? It's Mr. Moore here. We're going to do a little review of those constant acceleration questions in practice for the test that's coming up in a couple days. So let's take a look at the first question right here. We have a bike accelerates uniformly from rest to a speed of 7.1 meters per second over a distance of 35.4 meters. And you have to determine the acceleration of the bike. So we know this is going to be one of those constant acceleration equations that we have on our reference table. So let's just break it down, figure out what variables we have, and then from there we'll figure out which equation and we'll solve. So a bike accelerates from uniformly from rest. So we see that from rest, so we know that VI is going to be 0. It's accelerating to a speed of 7.1, so we know that's going to be our VF. All right, and it's over a distance of 35.4, so that's our D. And it's asking us here to find the acceleration, so that is our unknown. So we need to look, do we have an equation that deals with these four variables? And we most certainly do. That's our VF squared equals VI squared plus 2AD. All right, we just got to substitute in now, so we have 7.1 squared equals 0 squared plus 2 times A, which we're trying to figure out, times D, which was that 35.4. All right, we plug these numbers into the calculator. We're going to get that 50.41 is equal to 0 plus, I multiplied the 2 and the 35.4, which gives me 70.8, and then times the A. Okay, the 0 is just going to drop out here, so I get 50.41 is equal to 70.8 times A. Divide each side by this, so I can get the A by itself. And in the end, I'm going to get that A is equal to 0.712. Now this is acceleration, so that's meters per second squared. All right, guys, and that's the first one. So let's jump right to the next one. Not save that. Let me go ahead and copy that. So here we go. Number 2. We have Upton Chuck is riding the giant drop at Great America. If Upton free falls for 2.6 seconds, what will be his final velocity? So in this case, something is free falling. We know that in free fall, we're always dealing with constant acceleration, and that's at 9.8 meters per second squared. So in this case, it's a ride. It's going to start from rest. So we know that our VI, our initial, is going to be 0. All right. He will free fall for 2.6 seconds, so that's going to be our time. It's 2.6. Let's fix that there. And we know that this is free fall, so we know that that acceleration is that 9.8. And then his final velocity, VF, that's our unknown. So we have to look, do we have an equation that deals with these four variables? And that's going to be our final velocity is equal to our initial velocity plus A times T. So we just got to substitute in here. The VF we do not know, but that's going to be equal to our initial, which was 0, plus A, acceleration due to gravity, that's that 9.8, times T, which is 2.6. All right, we throw these numbers in the calculator here. We're going to get that VF equals 0 plus 25.48. All right, so in the end, we have our final velocity is equal to 25.48. This is a velocity, so that's meters per second. All right, so let's take a look at 3 and 4, and then we'll pause this video here. So open up a new file, not saving that. All right, so question 3. An airplane accelerates down a runway at 3.2 meters per second squared for 32.8 seconds until it finally lifts off the ground. So determine the distance traveled before takeoff. So we have an airplane accelerating down a runway, so we can assume that the airplane started at rest. It's accelerating, so that's going to be our A, 3.2, for 32.8 seconds, so that's definitely a time, 32.8. And they want to know, determine the distance traveled. So D here is going to be our unknown. That's a little sloppy. All right, well, we need to look. Do we have an equation that deals with these four variables? And this is going to be our D equals initial velocity times time plus 1/2 AT squared. The T's are a little sloppy. So the D, that's our unknown, so we're going to leave that. The initial velocity was 0. The time was 32.8 plus 1/2 A, which was 3.2, times T squared, so that's 32.8 squared. All right, D still unknown, the 0, this is going to turn into 0 for everything over here. Plus, if we throw all these numbers in the calculator, we're going to get 1,721.344. So in the end, we just have distance, right, that the airplane's going to need is going to be 1,721.344 meters. This is distance, so it's meters. All right, so let's do one more. All right, new file, open up Word. All right, so a feather is dropped on the moon from a height of 1.4 meters. The acceleration of gravity on the moon is 1.67 meters per second squared, and we have to figure out the time for the feather to fall to the surface of the moon. So now we're on the moon. We're not on Earth anymore. So our constant acceleration is no longer that 9.8, okay? We're on the moon. That's only Earth. In this case, they give us an acceleration of 1.67 meters per second squared. All right, they've given us a height of 1.4 meters. All right, and since we're dropping something, we know that that initial is going to be 0. And they want to figure out the time in this case. So time is our unknown. So do we have an equation that deals with this? And this is going to be our D equals VIT plus 1/2 AT squared. All right, so our distance was 1.4. Our initial velocity is going to be 0 times t plus 1/2 the acceleration of 1.67 times t squared. So we have 1.4. This is going to just drop to 0. Plus, and if we throw this in the calculator, 1/2 times 1.67 is going to be 0.835. And that's times t squared. So in this case, the 0 is just going to drop out, so we get 1.4 is equal to 0.835 t squared. All right, I'm going to divide each side by this 0.835 so that it cancels on my right-hand side. And in the end, I get that t squared is equal to 1.4 divided by 0.835, which is equal to 1.68. So I'm going to take the square root of each side, and I'm going to get in my end that t is equal to 1.29. And this is a time, so this is 1.29 seconds. All right, guys, well, that's the first couple of questions, so you can go ahead and click on the second video and watch the last couple questions.